In this video, we're going to take a look at some of the ways that medications are extracted and purified once they've been synthesized. So after a drug has been synthesized, two steps need to occur. First, you need to extract the drug from the reaction mixture. And then second, you need to purify the drug because we don't need all the other stuff that goes along with it. So let's talk first about the extraction of the drug from the reaction mixture. If a drug precipitates out in the reaction itself, so something like the synthesis of aspirin, then you don't need to go through extracting further. You would just start the purification process. But most drugs remain dissolved in the solution, the reaction mixture, so you do need different sort of techniques. And if this is the case, this is typically done using a process called solvent extraction. It involves a special type of equipment called a separatory funnel. So it looks like this here, where you have openings at both ends. Kind of looks like a burette, I guess, with the opening at the bottom here. And basically you put your reaction mixture in here and you add it to a mixture of two different solvents. One's going to be organic and one's going to be aqueous. So something that's nonpolar and then something that's polar. Typically what happens is the medication or the drug is going to separate from the rest of the reaction mixture based on its solubility. And drugs typically will separate into the organic layer, which is the nonpolar layer. And then everything else usually will separate into the polar layer instead. In terms of where those particular ones end up sitting, it's going to depend on density of the solvent itself. So the high density solvent is going to end up on the bottom here. And the low density solvent is going to end up on the top here. So you do have to know the densities of your solvents to know where potentially your drug is going to lie based on where the nonpolar layer is going to end up being. So we don't just do one round of extraction. We actually do several rounds just to try and increase the yield. And what you're left with then at the end is a solution of your nonpolar solvent here with your drug inside. So you need to get rid of the nonpolar solvent. And the way that we do that is we use a roto evaporator. So you put your solution mixture in here. It's a round bottom flask and put into a water bath. And essentially you're trying to evaporate off all of the solvents, so you're left with just your medication or drug left over. And so we'll also put in a drying agent in here. This is usually anhydrous magnesium sulfate, and that's just added to get rid of any residual water. And then the drying agent is filtered off as well, and the organic solvents removed using this rotary evaporator. Now, once we've fully evaporated our organic solvent and we're left with just our medication, we still need to do a little bit of purification. And it depends on what it is, like what sort of strategies you use. So recrystallization, we've seen before with aspirin. So if you want to go back to that video and watch that again, you can go take a look. The other ways you could do is distillation or fractional distillation. So we're going to talk about that in a minute. Or you can use various different types of chromatography to separate out your different components. So let's just focus on fractional distillation specifically. So distillation itself is great when you have two substances that have very different boiling points, but fractional distillation is a little bit different because it's used to separate liquids that have similar boiling points. And basically what we do is we put our mixture in here, we heat it up, and then it's going to go through this fractionating column that's packed with glass beads. We have a thermometer up at the top here to measure and monitor the temperature. And then the mixture of the liquids is heated, and then the liquid with the lower boiling point is going to get collected by condensing the vapor. So we're going to have condensation happening down through here because we're pumping through cold water, and then our products are collected over on this side here. Now there is more that goes into fractional distillation than we're going to get to in this video here. We do need to understand a little bit more about equilibrium between liquid and vapors, and so we'll take a look at that in our next video. But that's it for this video. We'll see you in the next one.